So 12.9 goes over solving radical equations. When we're doing these, I give you 3 steps to pretty much go by. You want to first isolate your radical. Then you're going to square both sides of your equation to remove the radical. And then you're going to isolate the variable. So if we look at the first example, we just have the square root of x is equal to 7. If you take this and you square both sides of this equation, because your index is 2, it cancels out your radical, so that way you just have the x on the left side of your equal sign, and it's equal to 7 squared, which is 49. That's it. So isolate the radical. In this case, our equation started with the radical isolated. Square both sides, or take the index of that radical and raise both sides to that power of the index, and then you have your answer. For example B, we have 3 times the square root of x is equal to 18. You want to isolate that radical first. So we're going to divide each side by the 3 that's in front of it. We have the square root of x is equal to 6. Your radical is isolated. It has an index of 2, so we're going to raise each side to the second power. That cancels out your radical and the power on the left side, so where you just have the x, and 6 squared is 36, so x is equal to 36. Just like with any equation that we've gone over so far this year, if you plug in your answer for that variable in the very beginning of that equation and you simplify it, you should get a true statement if your answer is correct. For example C, we have 140 is equal to 2 times 9.8 times d, all under the square root. That square root is isolated. You do not need to do anything underneath that radical right now if you don't want to. You can just take both sides and square them. It would get rid of the radical and the power on that right side. So you just have 2 times 9.8 times d is equal to 140 squared. If you do 140 times 140, it's going to give you your answer here. Hold on, let's do 4 times 0. All right, so we have 19600, so 19,600. From here, if you want to divide each side by the 2 to start with, you can do that, so that way you're not multiplying. You get that d is equal to 9,800. Oh, sorry, 99.8d is equal to 9,800. Divide each side by that 9.8. And you get that d is equal to 1,000. For example D, we have 15 is equal to the square root of 5 times 7x. If you want for this one, if you want to multiply it first to start with, we can do that. We're just going to get 15 is equal to the square root of 35x. Your radical is isolated, so we're going to take each side and we're going to raise it to the second power. So it's going to cancel out your radical, and you're going to get 225 is equal to 35x. From here, we're going to divide each side by the 35. So this is going to give us that x is equal to 225 over 35. We can divide both of these by 5. And this is going to give us 45 over 7. If we look at our next set of examples, these have expressions on the same side as that radical, and we want to isolate that radical before we get rid of it. So with any of these, you're going to undo addition or subtraction before you undo multiplication or division in order to isolate that radical. For example, 2a, you have the square root of 5x plus 1 plus 2 is equal to 6. You want to isolate that radical, so we're going to move that 2 over by subtracting it from each side. This is going to leave us with the square root of 5x plus 1 is equal to 4. Our index is 2, so we're going to take both sides and square them. It gets rid of our radical, so we have 5x plus 1 is equal to 16. We're going to subtract the 1 from each side. We have 5x is equal to 15. We divide each side by the 5. And we have that x is equal to 3. For example B, we have the square root of 2x plus 4 minus 7 is equal to 3. We're going to start this one by adding the 7 to both sides. So we have the square root of 2x plus 4 is equal to 10. From here, square both sides to get rid of that radical. So we have 2x plus 4 is equal to 100. Subtract each side with that 4. We have 2x is equal to 96. And then divide each side by the 2. And we get that x is equal to 48. For example C, we have 3 times the square root of 5x minus 4 is equal to 18. For this one, we're going to divide each side by the 3 to start with. So we have the square root of 5x minus 4 is equal to 6. We're going to square both sides. And we have that 5x minus 4 is equal to 36. We're going to add the 4 to both sides. And we get 5x is equal to 40. Divide each side by the 5. And you have that x is equal to 8. For example D, we have 5 times the square root of 6x minus 2 is equal to 20. For this one, again, we're going to just divide each side by that 5 to isolate that radical. We have the square root of 6x minus 2 is equal to 4. We square both sides. And we have 6x minus 2 is equal to 16. We're going to add the 2 to both sides. We get 6x is equal to 18. We divide each side by the 6. And we have that x is 3. With these, you want to always make sure that you check your answers. The reason why is because sometimes you will get an answer that when you plug it in doesn't necessarily work. So if we look at the first example in this section, we have the square root of 11x squared minus 63 minus 2x is equal to 0. When you do this, again, you want to isolate that radical. So we're going to add the 2x to both sides. We have the square root of 11x squared minus 63 is equal to 2x. We're going to square both sides. So we have 11x squared minus 63 is equal to 4x squared. You want your x squareds together. So we're going to subtract the 11x squared from each side. This gives us negative 63 is equal to negative 7x squared. We're going to divide each side by the negative 7. And we get that 9 is equal to x squared. We're going to take the square root of both sides, and we get that x is equal to plus or minus 3. This means you have 2 answers, one that's negative 3, one that's positive 3. You want to plug these in and check both of them to make sure that they are in fact a solution. If you plug in the negative 3, you have the square root of 11 times negative 3 squared minus 63. That gives you 6. If you take 6 and you subtract 2 times negative 3 from that, it gives you 6. 6 is not equal to 0. Hold on. 6. No. So if you have 6 and you subtract 2 times negative 3, you're adding 6. So that gives you 12. And 12 is not equal to 0. So this x is equal to negative 3 is not a solution. Try the positive 3. 11 times 3 squared is 11 times 9, which is 99. 99 minus 63 is 36. The square root of 36 is 6. If you subtract 2 times 3 from that, that is 6. So 6 minus 6 is 0. That one works. So the only one that's your solution here is that x is equal to positive 3. For example, B, we have the square root of 3x squared plus 9 is equal to 2x. Our radical is isolated here, so we're going to square both sides to start with. We have 3x squared plus 9 is equal to 4x squared. We're going to subtract the 3x squared from each side. We get 9 is equal to x squared. We take the square root of both sides, and we get that x is equal to plus or minus 3. So once again, you have that x is equal to negative 3, and x is equal to positive 3. You got to check both of them. So if you do the square root of 3 times negative 3 squared plus 9, that's going to give you 3 times 9 plus 9, which is 27 plus 9. That's 36. The square root of 36 is 6. If we do 2 times negative 3, that's negative 6. So this one does not work. If you try the positive 3, you just have the square root of 36, which is 6, is equal to 2 times 3, which is 6. And 6 is equal to 6. That's a true statement. So this one is the only solution here. If you see that both of these, your answer is the positive number out of the two possible solutions, it doesn't necessarily work out to always be the positive number. That's your answer. So you do need to make sure that you check both of these, because sometimes it'll be both of them that are solutions, sometimes it'll only be one. And it doesn't necessarily mean that it's only going to be the positive or it'll only be the negative.